From our beginnings, the human race has endeavored to extend our reach. And now we're headed for the final frontier.
We should be a two-planet species.
From an outpost on the moon to a full-fledged colony on Mars.
It could be a challenge. It could also be a disaster.
Right now, we're building the rockets to get us there, and the machines we'll need to survive. Do you have the right stuff to join the crew?
I want 2 Scotties and 2 Spocks.
The countdown begins now. The universe, colonizing space. Colonizing space is no longer the stuff of science fiction. It's likely the first humans who will live on another world have already been born on Earth. For these pioneers, this adventure will be the ultimate cosmic camping trip.
You need to bring everything you need with you. You need to bring a place to live. You need to bring the food you're going to eat. You need to bring the water you need to drink. Now, on Earth, at least, you don't need to bring the air you breathe, but when we go into space, we'll need to bring that too. Everything we need has got to be with us. If something's missing or if something breaks, it could be a disaster. We need to have everything we're going to use with us. We need to have it working. The success of space colonization will depend upon it.
The ambitions to settle somewhere out there go right to the core of our existence.
Compelling reasons to colonize space are to see if we can expand the range of our activities beyond the Earth, or are we really confined to the Earth? I think that's an important question we need to know the answer to. The second one is, what's the role of life? We have on this Earth a phenomenon called life. Is it destined to spread beyond the Earth? We are the species that can cause that spread.
Carl Sagan, the great noted astronomer, once said that we should be a two-planet species. That is, we should colonize one planet and also have the Earth because, for example, the Earth is in the middle of a cosmic shooting gallery. There are comets and meteors whizzing all over the place on a scale of hundreds to thousands and millions of years. And we need a spare planet because it's simply too precious to put all life on simply one planet.
In the vastness of space, there's one destination above all others that stands out as prime real estate for colonization.
Mars is the grand prize of the solar system. It's the closest planet which human beings can settle. It's the closest planet that has all the resources needed for life and civilization.
Mars, the 4th planet from the Sun. It's about half the size of Earth, and at its closest pass is roughly 35 million miles away. The ancient Romans associated its red color with hostility and named it after their god of war. But far from hostile, Mars has the potential to be the most hospitable planet after the Earth. The gaseous outer planets offer no solid ground. Among the inner planets, Mercury is too scorchingly close to the Sun. And Venus, though similar to Earth in size, is baked to 870 degrees Fahrenheit by a runaway greenhouse effect. It also has an atmospheric pressure that would crush any would-be human settlers. Mars does have its own pitfalls. It actually has extremely low atmospheric pressure, which would cause your blood to boil and then freeze. But a pressurized spacesuit can overcome that danger. And while it's cold on Mars, with typical daytime temperatures 20 to 40 degrees below zero, humans could easily survive wearing proper protection. Most important, the red planet, with its carbon dioxide-rich atmosphere, seems to have the natural resources we would need to keep a colony running.
On Mars, we have carbon dioxide from which we can extract oxygen and make fuels from it. There's water vapor in the atmosphere and also in the polar caps. The soil on Mars, the regolith, has the minerals and various compounds we need in order to set up a colony on Mars.
Today, Mars is a frozen desert. But photos taken by space probes show clear evidence of erosion. This means that not only did Mars at one time have water on its surface, but also that it may have once supported life. Finding evidence of previous life, even microscopic organisms, might make the difference between whether we establish a short-term base or a more permanent colony there. Long-range mission planning is already underway at NASA. The space agency plans to return man to the moon by 2020 as a stepping stone to a Mars mission.
One of the major themes for the lunar exploration is called Forward to Mars. And within that theme, we'll be constantly thinking about how we will operate on Mars. The astronauts will be involved with studying how humans react to the planetary environment, how hard they can work, how much sleep they need, how much entertainment they need, how they will relate to mission control. We need to learn to deal with all of these issues that come with people living in far-reaching environments.
An important step in preparing for a long wilderness trip is testing the gear. Setting up everything in a local spot, even in your backyard. Make sure you've got everything you need and it all works. In that same way, setting up a base on the moon is a practice run for setting up a base on Mars. We learn what to do, we learn all the equipment we need and how it works. We get everything working just right.
Everything includes versatile robotic machines like Athlete, which stands for All-Terrain Hex-Limbed Extraterrestrial Explorer.
Athlete is designed to carry cargo on the moon or Mars. The most important cargo we could carry would be a habitat. That's usually the largest single piece of any human mission.
But Athlete can do much more than just haul cargo. Each side of the machine is equipped with high-definition cameras that give a 360-degree view of the surroundings and display it to an operator based either on the planet, in an orbiting spacecraft, or back on Earth. And each limb is like its own self-deploying Swiss Army knife.
One of the things it can do is take one of its limbs and grab a tool out of a tool holster and use that tool to excavate. So we have built scoops and drills and grippers and other tools. One of the most interesting things is that if a leg were to fail on Athlete, the two adjacent legs could in fact grab tools and disconnect the one leg that's failed and amputate it and leave it on the surface.
With equipment like Athlete, astronauts will be able to establish a long-term base on the moon and test how self-sufficient they can be. Only then, according to NASA, will we really know if we're ready to go to Mars.
The real acid test of our understanding how to live in space will to take a crew of, say, 6 people, put them on the far side of the moon where they cannot see the Earth and have the psychological disadvantage of not being able to connect to the Earth, and see if they can exist for a year on their own with the systems that we designed for them. If we're able to actually do that kind of a test and experiment, then I think we will have checked the box that, yes, we're ready to move out into the solar system and settle more difficult regimes such as the planet Mars.
The moon's close proximity to Earth, about 240,000 miles, only a 3-day trip, makes it a convenient proving ground. But its environment is vastly different from Mars.
Mars compares to the moon as North America compared to Greenland in the previous age of human exploration. I mean, Greenland was closer to Europe. Europeans got there first, but ultimately it was too poor an environment for a new branch of human civilization to really develop in. Same with the moon. The moon is closer to the Earth. We got there first, but as a place for settlement, Mars is a much better place to go.
Mars has more water and other useful natural resources than the Moon. It also has an Earth-like day-night cycle that lasts only about 40 minutes longer than ours. That's why the Mars Society, an organization of scientists, researchers, and NASA personnel, thinks we should skip the Moon entirely and head directly for a rendezvous with the Red Planet.
Mars Direct is a plan for sending humans to Mars without the need for futuristic science fiction spacecrafts and without the need for a lunar base.
The Mars Direct mission plan proposes 2 launches. The first sends an Earth Return Vehicle, or ERV, to Mars.
Land this on Mars, and then you run a pump and you suck in the Martian air, which is mostly carbon dioxide. And we react that carbon dioxide with a little bit of hydrogen that we brought with us from Earth to produce a large supply of methane and oxygen rocket propellant. So now we got a fully fueled up Earth return vehicle sitting, waiting for us on the surface of Mars.
The second launch sends a crew habitat module to Mars. After conducting their mission on the Red Planet, the astronauts board the ERV to return home and leave behind the habitat module.
Each time we do this, we add another HAB module to the base. And after a few missions, we've built the beginning of the first human settlement on a new world. There is nothing in this that is beyond our technology. It's simply a question of having a little bit of moxie, a little bit of will.
But to skeptics, the Mars Direct mission plan is a non-starter.
If we tried to go to Mars directly, the first step would be something like 20 years of preparation and testing, and at that point, the public will get very bored with the idea of going to Mars. We believe that we can get to the Moon in a time frame where the public will be heavily engaged in human exploration of space, and that will enable us to get to Mars in some sense faster because we'll have more confidence and we'll have less risk to human life.
Getting to Mars, whether by direct mission or only after further lunar exploration, is just the first step towards colonizing the planet. But getting there will be as challenging as living there. Surviving the journey will be the ultimate test of human endurance. The trip to Mars is 6 months long. That's when the Earth and Mars are at their closest alignment, making it the best time to depart.
Earth and Mars both go around the sun, but they go around at different rates. And every 2 years, Earth and Mars are on the same side of the sun, and so then that's when it's close, and then it only takes 6 months to get there. When Earth and Mars are on opposite sides of the sun, forget it. You're not going from one planet to another, not with the technologies we've got. You got to wait for warp drive or something like that.
There are new hardware elements that need to be developed to enable a human flight mission to Mars, but no new technology. Everything we need to make, we know how to make. We are much closer today to being able to send humans to Mars than we were being able to send men to the Moon in 1961 when Kennedy started the Moon program. And we were there 8 years later.
0, all engine running.
The new hardware will include the Ares, the next-generation rocket that will launch man to the Moon and beyond. The Ares should be ready for liftoff within a decade. It's about the size of the Saturn V of Apollo fame. Taller than a 36-story building, the Saturn V was the largest and most powerful rocket ever launched, capable of delivering a 53-ton payload into lunar orbit. But the Ares, using boosters derived from the space shuttle, will be able to muscle an extra 22 tons of cargo on each trip to the Moon.
So if you have very large rockets, you can have fewer launches in order to assemble the spacecraft that goes to Mars. So the large rocket is really a product of the desire to ultimately look at Mars in our exploration scenarios.
New hardware will also include Orion, the crew vehicle. It will be more than 2.5 times the volume of an Apollo capsule. On its missions to the moon, Orion will dock with a lunar lander sent into space on a separate launch. Unlike Apollo spacecraft, Orion will orbit the moon unmanned, while lunar explorations take place. The astronauts will redock with Orion for the return to Earth. This new crew vehicle will borrow much of its hardware from the space station.
And this is a place where a few tourists come, so basically...
In 1997, retired astronaut Jerry Linenger spent about 5 months, nearly the length of time it would take to get to Mars, aboard the Russian space station Mir. While on the long mission, he overcame many dangers, including the most severe fire ever on an orbiting spacecraft. A chemical leak ignited a blaze that lasted 90 seconds, threatening the crew.
I processed a lot of the things that I think pretty much saved our lives are these oxygen breathing devices, and during the fire, of course, that had to go on quickly.
If anybody knows firsthand how the hardware, including life support systems, will work on the spacecraft taking man to Mars, it's him.
Down here on Earth, you take so much for granted. You know, we're out here, sunshine, the fresh air all around you. You know, in space, you have to make it. You've got to make the oxygen. Up there, you're in a closed ecosystem. You have to recycle, you know, whatever you can.
And the toilet itself is over this way, and it's a very simple design.
For example, we take the urine, collect it using a little funnel, little suction device.
For the male or female urination is this tube here is used.
We'd collect that up, we'd convert the urine into water, water to oxygen, and we would breathe our urine inside that closed ecosystem of the space station.
Of life. I hope you've got a feel for the space station as we flew you through it.
New hardware will also provide power from clean, reliable sources. We're going green to the red planet. Solar panels will do the job on the return to the moon. But the longer journey to Mars will require another power source.
As we get off to Mars, the solar insolation, the intensity of sunlight at Mars, is only about half that at the Earth. So solar panels are less effective. We may have to think carefully about using nuclear power sources in some of these spacecraft. And in fact, people are thinking seriously about nuclear power sources on the surface of the moon in order to generate long-term power and not have to worry about the periods of darkness on the moon where you don't have sunlight and you have to bring batteries up to store power.
But despite all the new hardware, the journey to Mars will still have its share of potential hazards. Just like any trek to an unfamiliar place.
Imagine you're on a wilderness camping trip. You leave home, the familiar surroundings that you're used to. You go out on a long trip, potential dangers, hazards, rock slides, avalanches, getting lost, equipment breakdown, all sorts of possible problems. But you want to go anyway. You prepare, you go out. It could be an adventure. It could be a disaster. Going to the moon and Mars is going to be like that too. You leave the familiar surroundings of Earth, you go out in space, potential problems, issues, equipment breakdown, many of the same kind of problems that you might have on a camping trip, the astronauts might face on Mars. It could be a challenge, it could also be a disaster.
A major hazard the crew will encounter will be prolonged weightlessness in the zero-gravity environment.
Easy, Georgie. Oh yes, it's true.
Relieved of bearing its usual load, the human skeleton starts to deteriorate. There's a loss of calcium phosphate, a chemical critical to the rigidity of bones, and the number of bone cells actually decreases.
For 24 hours a day, you're floating, and your body very smartly starts physiologically to adapt to that new circumstance. So in order to counter that, try to keep your strength up, I get on a treadmill. 2 1-hour periods a day, it's about all you can muster up there. In spite of that, you know, came back at about 65% of my pre-flight strength level, a lot of muscle atrophy, and more significantly, about a 14% bone loss. You know, hips, lower spine. You get up in space, you're floating effortlessly, the bone just keeps dumping calcium. And that could be a showstopper on a long-duration flight.
It was only through intense physical training after his return to Earth that Lineker was able to reduce his bone loss from 14% to 2%. The debilitating effects of weightlessness remain an issue that must be addressed before we set foot on Mars, let alone colonize it. Research continues on a possible solution.
A lot of people have looked towards artificial gravity, which means you spin the spacecraft up and you end up with a gravity, and that would sort of help load your bones, because when you're in weightlessness, your fluids are shifting, your bones are unloaded, and you lose about 2% of your bone mass per month. It would be a large hurdle because in order for crews to be healthy when they arrive on Mars, they need to be strong for the entire trip.
Nobody's ever built a rotating spacecraft before, so nobody wants to be the first person. But most people believe that some kind of artificial gravity with a rotating spacecraft on the way to Mars is actually the way to do the mission.
Missions headed for Mars also face danger from solar storms. High-energy particle bursts unleashed from the sun could wipe out a crew if they aren't prepared for the onslaught.
So radiation is one of the largest showstoppers in terms of technology that needs to be developed for a future vehicle. The easiest way to deal with that is just to make a storm shelter, so that if you can somehow predict when the solar storms are approaching, which you would do with various navigation satellites and relaying them from Earth, then you could get into the shelter and wait it out and then be able to go back into the spacecraft. And then similarly on Mars, when you know that there's a storm coming, you would go into a shelter.
The journey alone will make colonizing Mars an unprecedented challenge, but the enormous risks come with historic rewards. No decision is more important than who gets to go. Think you have what it takes to be a space pioneer? Get in line. There are people already training for the job. Colonizing Mars will require a special breed of people. With missions that could last more than 2 years, selecting those with the right stuff to be planetary pioneers will be critical to the success.
2, 1, we have ignition.
The cost of a launch, in the billions of dollars, and the tight quarters of the spacecraft will keep the number of crew people to a bare minimum.
I believe that number is 4. It's the smallest number you can send and divide the crew up into 2 groups and have no one be alone. And it's the smallest number that you can send in which you have the 2 primary skills of the mission both multiply backed up.
A crew of that size would consist of 2 ace mechanics who can fix anything, and in doing so, save lives. Joining them would be 2 field scientists, the intellectual payload.
So in Star Trek terminology, I want 2 Scotties and 2 Spocks.
Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
People think that astronauts are tough. They will just always obey commands and will operate according to plan. But they are human, and humans in these situations do develop strange psychological reactions. We really have to understand that, because that's part of the crew selection process.
All right, I'm going to fly into the node.
Astronauts will have to adapt to the confined space of the crew vehicle or habitat. If you're claustrophobic, forget it.
And we actually test for that. We put you in sort of a ball, zip it up, it's totally dark, you're crammed in the thing.
Inside the sleep cabin, there's also a little window. Sleeping bag sitting right here. This just happens to be the commander's sleep station.
And they have heart monitors on you. In my case, I fell asleep. They finally came, opened the thing up, said you're fine. But if you don't fall asleep in a closed space, you're not the right person.
Dealing with being the only life forms on an otherwise lifeless planet will be another major psychological challenge.
Out there in space, you truly are just removed from mankind. And, you know, the interactions we have in life with the colleagues, friends, family, you just sort of take them for granted down here, but up there, all of a sudden, it is isolation like I've never felt before. If you're not totally comfortable with yourself, you're going to have some very, very difficult times up there.
So it's been 4 months simulated Mars mission. Everyone's doing great.
To train people for this extreme mission, the Mars Society has built 2 Mars analog research stations to practice simulated missions. Crews consisting of as many as 6 people, mostly university scientists and NASA personnel, operate under many of the same constraints that astronauts will endure on Mars. They don't go outside without wearing spacesuits. They live on Martian time, 37 minutes longer than an Earth day. Their communication with Mission Control in Denver is on a 20-minute delay to simulate the time it takes for a radio signal to go from Mars to Earth. Maybe most challenging, they must coexist in a habitat with minimal personal space.
By doing that, you find out what works on Mars and what doesn't, and what kind of skill mix, what character mix you need in the crew, what technologies are likely to be most useful to the crew, how to organize the crew, who should command the crew, how tight you can ration the water and still sustain morale while you're doing this kind of work. This is not like a lunar mission which only lasts a week, where you can get 3 test pilots and they can just suck up the fact that they don't really like each other for that duration time and get along.
Crews first go to the Desert Research Station, located outside Hanksville, Utah, to conduct short-term missions lasting 2 weeks. During that time, they perform EVAs, extravehicular activities, such as collecting soil samples for geological study. After completing their desert work, the crews are ready to join longer missions, lasting up to 4 months, at the research station on Devon Island in the Canadian Arctic.
Devon Island is one of the key places that you can conduct Mars research because of its isolation. It's the largest uninhabited island in the world. There are no signs of life around, maybe some bacteria and algae growing on the rocks. And also because the crater formation that the research station is located on is similar to a crater that you would typically find on any planet. There's a lot of permafrost up in the Arctic, and drilling into there looking for microbial life could be a similar experiment to what you would do on the surface of Mars.
We're going on our radiation/weather station EVA. We'll be taking readings of the surrounding area.
In addition to conducting field research, scientists at both stations also study each other as part of what they call human factors.
The human factors research looks at the interactions between humans and computers, the interactions between humans and their environment, and with each other. By learning how we're going to react with each other in different situations, we can then learn how a crew will react together on the way to Mars or on the surface of Mars.
A lot of our findings sound very obvious, but they have not really been paid attention to before. For example, the very first thing you learn is that this activity, a field exploration while wearing a spacesuit, is a physical activity. The amount of exploration is very much contingent upon your physical fitness. So what is this saying? It's saying you don't want to go to Mars in 0 gravity if you want to actually get anything done, because you'd be deconditioned.
Another key finding was determining how little water humans need to survive. It's a drop in the bucket compared to the 125 gallons a day the average person uses.
We have found that with careful rationing and with the right kind of crew, we can limit water use down to about 3 gallons a day per person, taking sponge baths every other day instead of showers every day, and carefully rationing it. But if we try to cut the water down much below that, then it does in fact start interfering with morale in a serious way. And this is a very important number to know from the point of view of the engineer designing the mission and how much mass you need to ship.
The Mars Society shares data from its Arctic and desert research stations with NASA. The space agency will study the findings as it plans a future base on Mars. the next step to colonizing the planet.
See you soon. Space.
The year is 2040. The destination? Mars. After decades of careful study and research, the first human explorers are on their way to the Red Planet. After completing the 6-month journey from Earth, the longest manned space trip in history, it's time to land on Mars. But where's the best place to touch down?
You want areas that are geologically diverse, where there's a lot of different things to explore within a reasonably small radius of action. You want to definitely include areas that had water in them in the past, because that is where there could have been life on the surface. That's where you want to hunt for life. You want to go to places that are either in the temperate or tropical regions of the planet, because you don't want to go to a place where it's going to be dark for 12 months at a time.
By these criteria, the best place to land would be just north of the Valles Marineris, within driving range of runoff areas. Not far from where space probes Pathfinder and Viking 1 touched down. It's also the best place to establish a base camp that will function much like one in the wilderness on Earth.
Here in a remote wilderness area, we can establish a base camp because we have everything we need. We also rely on the environment. We get oxygen from the environment. We get water. We get wood for fire from the environment. Well, now let's imagine colonizing Mars. On Mars, we also rely on the environment. Colonizing Mars is going to require using the oxygen from the Mars atmosphere that we could derive from the carbon dioxide, growing food on Mars, getting water from the atmosphere on Mars. The same mix of resources from the environment and material that we've brought with us is what's required to allow us to successfully colonize space.
Once the base has been established, the primary objective of early missions is to search for evidence of life in the past and the present. Using radar, astronauts attempt to locate groundwater within a few hundred yards of the surface, then bring it up with drilling rigs. Samples will be studied under microscopes in the crew habitat to see if they contain evidence of life. If the planet proves capable of supporting life, then it would be viable for astronauts to construct greenhouses and cultivate crops using Martian water, soil, and sunlight. As they search for life, these pioneering astronauts will have to contend with the one force that could bring the lofty ambition to colonize Mars back down to Earth. That's gravity.
The gravity on Mars is 1/3 the gravity on Earth. We don't know if that's enough gravity to allow for healthy bones and muscles. If Mars gravity is not suitable for human long-term survival, then it may become the place we visit. We may go there for a week or so. It's a tourist attraction, but it's not a home. And so that's a fundamental question that needs to be answered. Is 1/3 gravity enough gravity for us to live biologically fit lives? My guess is the answer is yes, but we have no direct data, so we can only guess.
Discovery and Alpha, capture confirmed. And ISS is in...
Getting direct data will be vitally important.
Houston copy.
So will communicating it to Earth. The lag time in radio communication between the Mars crew and mission control, as much as 40 minutes depending on planetary alignments, will affect how the astronauts conduct their research.
It certainly means that the Mars crew is going to have to be a lot more autonomous than you could have with human crews in Earth orbit or on the Moon. You're not going to be talking to the Mars crew, okay, now step 2 steps to the left and head towards the rock. They are going to have to make their own decisions, and I think more generally the Mars mission is going to have to be led from the front, and that the commander of the Mars mission will be in the Mars mission, and rather than have mission control, we will have mission support on Earth.
Good luck. Back to work now. Back to work, all you guys.
The habitat that will house the astronauts offers a preview of structures that could form the first settlement on Mars. As proposed in the Mars Society's direct plan, the initial habitat will be the crew vehicle itself. The tuna can, as its proponents call it, is about 20 feet tall and 27 feet in diameter. It has 2 decks, the upper level for cabins and a common area, the lower one for lab and workspace.
We have found in our field work that while these are tighter quarters than most Americans are used to living in, they're not that bad. You don't really feel that crowded. We tend to keep the private bunks very small so that we can maximize the public space, you know, the wardroom where people hang out. If you've got a healthy crew where the people want to associate with each other, then this is clearly the best way to ration the available space.
As more pioneers settle on Mars, it may be safer to move the growing community underground.
Because it's a terribly dangerous place. There are sandstorms that can hit and knock over any surface establishment. There's horrible ultraviolet cosmic rays effects. You're going to want to save people's lives, save their reproductive abilities. You're going to want to have a place where you can raise children. You're not going to do that at the Martian surface. You're going to be doing that underground. Under those circumstances, it would be more like vast urban malls. Probably very nicely lit, nuclear and solar power. It shouldn't be a terrible life, providing that they get to a tipping point in technology, a tipping point in support from the outside world.
Early missions to Mars, if conducted during optimal planetary alignment, will last approximately 2.5 years. That includes the 6 months to get there, a 1.5 year stay on the surface, and the 6-month return trip to Earth. During that time, we will know whether Mars can support life. If it can, that opens the door to the ultimate form of colonization. Terraforming the planet to make it more like the Earth. Once humans establish a self-sufficient base on Mars, the next major advance in space colonization, say advocates, will be to terraform the planet, a process that will make Mars Earth-like. Wherever humans have settled, they've remade the environment to suit their needs. Mars may not be any different.
Terraforming is perhaps the ultimate way to create a new Garden of Eden in outer space. And how would we do it? Take a look at Mars. Mars is a frozen desert. First, we would have to raise the temperature.
We know how to warm up planets. We're doing it right here on Earth, where it's not a good thing. Whereas on Mars, it would be a good thing. So in fact, we could do the same things we're doing on Earth, putting in the atmosphere greenhouse gases, which would cause the planet to warm. On Earth, that would be pollution. On Mars, it's medicine.
Calculations have shown that the amount of greenhouse gases that we need to introduce to Mars are reasonable. They're not really way beyond what we can imagine to produce. But the amount is also too large for us to bring it from the Earth to Mars. That means that those gases have to be produced on Mars. We would need to set up factories to produce those gases and release them into the environment.
These factories would combine elements taken from the Martian environment, convert them to non-toxic fluorocarbon gases, and vent them into the atmosphere. Experts estimate in about 100 years, these greenhouse gases will have terraformed a cold, dry, dead planet into a warm, wet, life-supporting world.
It's interesting to think about what would Mars look like after 100 years of warming. It would be bluer than it is today. You'd see large patches of water. You start seeing little fringes of green around the margins of these blue areas. And then with time, this infestation of green would move away and up and into the mountains. And eventually, you'd see a world of blue and green with little islands of red that remain, almost like national parks preserved.
Even in the first stages of terraforming, the temperature will rise and also the atmospheric pressure will rise. That will mean that humans will actually be able to go out just in suits that really press down on their skin in order to recreate some pressure and with an air mask. And that would really make it much easier to go outside. It would probably take quite a while for Mars to become really a place like this, where we're in a greenhouse at the Los Angeles Arboretum. It would definitely take a while before we have such a paradise as this. But we can start from very basic algae, mosses, maybe grasses.
While this is going on, genetic engineering of the people themselves could also be taking place, so that you are breeding in, either through selection of your offspring or possibly even genetic manipulation, generations of citizens who need less gear when they go out on the Martian surface. Their skin is less fragile to the ultraviolet, to the low density atmosphere. And eventually they just need their respirators less and less. As the atmosphere increases, so does their ability to meet the atmosphere halfway. And these would be the beginnings of the true Martians, the people who could actually make this world their own.
NASA itself is not interested in terraforming planets, partly because it sounds very science fiction-y, but partly because there are real ethical questions involved. You will find a lot of people who believe that human beings should not go into space because we will just destroy things in the way that we've destroyed our own planet, and that we need to preserve the Moon and Mars and the other planets the way they are for scientific investigation.
Whether we should terraform Mars is an issue for future generations to resolve. It's a very distant point on a space colonization timeline that could begin with this generation.
The one thing that we can probably predict is that we will see ourselves in other places of the solar system than the planet Earth. Space colonization will be driven by the normal processes that we've seen over human history of expansion of people from one place to another across frontiers. Space is another kind of frontier. It's a technologically challenging frontier, but the human species has been extraordinarily resourceful over its history in its ability to adapt and to overcome challenges like the frontier of space.
My son, maybe someday he'll follow in Dad's footsteps. And I would be awful proud knowing that you blazed the trail. And, you know, he can do it. You know, next generation, who knows where they'll be.
Space colonization will be the ultimate camping trip. It'll test our equipment, it'll test our planning, it'll test us. But it'll be worth it. We'll learn a lot about space, about our own Earth, and about ourselves.
Whether it happens on Mars or somewhere else, maybe even beyond our solar system, space colonization won't be driven by the desire to plant a flag, but rather a seed. In the future, when we gaze into the heavens and ask, "Is anybody out there?" the answer just might be, yes, it's us.